Hi, everyone, and welcome to another episode of Astro webinars. Today, what we're really going to be doing is kind of going through a webinar around how to get started with Astro. So going to start off with just a couple slides, kind of explaining who Astronomer is, who we are, and then go into how Astronomer is built, how Astronomer makes running, managing airflow easier and also more performant. And then I'm going to show you how to go from zero to a production development local environment setup. I'll show you how to deploy code, how you can write your DAGs locally, set up a CI/CD pipeline, and then use our suite of monitoring tools to help set things like alerts, use our environment manager for managing connections, and a whole slew of other things. But above all else, I like when these webinars are collaborative. We don't have a super large audience today, so really, want to make this feel a little cozier. So drop any questions you might have in the chat. If you want me to stop and spend more time on a particular area, I would love to do that as well. The goal of these is to help you. So, if you want me to focus on something else, let me know, and happy to spend more time on that area. I imagine it's probably also relevant to some other people. And before we get into today's events, I just want to highlight some upcoming events in kind of the Airflow verse. Number one, if you're in Vancouver and you like Airflow, there is an Airflow meetup at Amazon, and feel free to reach out to Danielle or anyone else at Astronomer about details and signing up for that. There's also a virtual town hall on February 7th. And then we'll be running another webinar in about 2 weeks on the 12th of February, focusing more on CI/CD for Airflow. So I'll touch a little bit on CI/CD today, but that one will be really a more dedicated session. So if that's an area of interest, highly recommend checking that out. And then here, you also have the Airflow Slack. So if you're not already a member of the Airflow Slack, super great place to meet other Airflow users, ask questions, look for jobs, and just generally kind of get to know more about the Airflow community. And Airflow tip of the week: use the skip if decision to make skip decisions for individual tasks at runtime. So this is kind of a runtime branch matrix, or branch operator, where now instead of having to have an operator that does this short circuit, you now can have a skip if and define that skip if function. So super cool little tidbit there. Now, if anyone else, pause on the screen for a second, but if you want to start a 14-day free trial of Astronomer, please scan this QR code. You'll receive $300 in credits. Also, this QR code will include a complimentary Airflow fundamental certification exam code, normally $150, but you get it for free. Great little badge to add to the LinkedIn profile. And really, with the free trial, you have full access to everything I'm going to do here today. Also, as I'm starting, show you where you can set up a free trial on our website if you want to show a colleague or anything. But yeah, you'll get to see the rest of how it really makes running Airflow in 5 minutes a reality, and it makes it really easy to manage your data pipelines and start scaling your data operations. So, Astro, Astronomer. What is the difference? Astro is our hosted managed Airflow product running on all 3 clouds. That is the most efficient way to run Apache Airflow. And so what I'm going to go through today, just a little agenda setting. First, going to have an intro to Astronomer, then just going to go through a bit of an architectural review on how Astronomer is built, give you an explanation of how we do things here that might be a little different to how you might run Airflow, or how other people, at your company might run Airflow, and then go into a demo. And that's really where I kind of want to have demo. I'd love to have the demo and Q&A combined, ask me questions throughout the demo. But going to be going through, hey, how do I go from creating a new account and all the way from there to having a production development environment, deployed code on that environment, and have it all running from my local machine into production. So about Astronomer, just to kind of give you again some additional context to who we are. We've become really the driving force behind Apache Airflow. We've kind of become the only company that's centered entirely on running Airflow really effectively. So we've built up large amount of expertise and are helping some of the largest organizations in the world manage their complex Airflow environment. And our relationship to the open source community is that we employ a lot of the top committers on the board. Our employees contribute the majority of Airflow code, but we also still are beholden to the community. You know, we're still ultimately a much larger community of 3,000 contributors. There's been over 350K GitHub stars. That Slack community I just mentioned is massive at 47,000. And our monthly downloads has honestly really exploded over the past year, has gone from around 11 million to 30 million. So just really parabolic growth, especially with, ML ops, more evolving use cases have become a really good fit for Airflow. And so that's, where also a lot of people are now coming to us because they're running at Airflow at scale and figuring out, hey, how do I do this effectively so it doesn't require an entire team to manage Airflow themselves? So Astronomer data ingestion, where we kind of sit and where Airflow and Astronomer sits within the data stack is really as the connection between your different data sources and really any data system, and then those consuming services, producing data products, producing LLMs, AI models, reports around customers, auditing, reporting. Those are definitely some really big use cases we see for Airflow. And just generally acting as the center of the modern data stack. And so that's where we've seen a lot of really large customers building really critical data products because Airflow is able to sit in at the center of the organization and orchestrate the massive amount of different components it needs to help pipeline and to allow pipelines to run, and also to have them run in a unified manner where you're no longer needing to link up point-to-point systems, manage different scheduling systems, and connect them all themselves. You have Airflow that sits on top of it all. And so we have companies like FanDuel that are able to, take advantage of some of the newest releases in Airflow, like deferrable operators, and decrease the amount of working nodes they had running on average by 40%, which corresponds to thus 40% savings in compute. So really where Airflow is evolving is, not only is it able to handle these use cases, but it's now developing to be able to do these efficiently, not requiring a really intensive compute, tons of compute overhead, but doing things like just-in-time computing, and allowing you to do things like democratize ML ops because you're able to do this a lot more efficiently, and have data and things run just when it's available rather than having really long sensor jobs that are costing a lot of money. And so where does Astro fit into the picture? So number one, we provide a scalable platform for deploying many Airflow environments. So as you'll see here, you have an Astro CLI, which is a local command line utility for developing Airflow locally, paired with Docker Desktop or the container service of your choice. You can start and develop your DAGs completely independently on your local machine. We also have Cloud IDE, or now rebranded as Astro Notebooks, which is another way to develop DAGs without really needing to write DAG code. And then you also have branch-based deployments, which are something I'll touch on, but a really cool development we have that's enabled because we can create a new Airflow environment in around 3 minutes from a template. And then that's enabled some developers to have a workflow where when they're ready to deploy code, they create a new branch. That new branch creates a new environment. And then that developer has their own environment that is then deleted whenever that branch is merged into a shared dev branch. So enhancing developer productivity by giving you a easy to use platform for running, deploying, and managing Airflow. Then on top of that, because we have this common platform that we're able to optimize for really large customers and also learn from these really large organizations of how do we optimize and solve for these very specific problems. That's where we're able to do things like having worker auto scaling that goes to 0, elastic infrastructure that can be turned down, spun up. You have the ability to hibernate deployments with Astronomer. So no need to have dev environments that are up and running 24/7 when they're only used during working hours. Also a built-in connection management system, high availability, the ability to do in-place upgrades and rollbacks. So you can both upgrade your environment without taking it down. And if something goes wrong, you can roll back to a previous version. And then also task optimized compute, the ability to have different worker queues of different sizes on the same Celery environment. Then on top of all this, making it all easy to monitor, giving you the ability to have cross-deployment, visibility, and health. Airflow itself doesn't really have a concept of managing multiple airflows. And so that's a big part of what we provide, is the ability to have, hey, I can monitor all of these airflows across all of my teams. I can have data-centric alerting that tells me when things are failing, so I don't have to actively monitor it, but I can passively monitor it and only respond to instances that I can now easily set up alerts to monitor. And then also things like data-powered applications, critical operational processes, analytics and reporting, MLOps, things I talked about earlier. This is what is enabled by having this type of platform. And so before I get into the demo, I'm going to probably send this out after, but just some additional resources. We have a ton of docs and learnings, tutorials, some of which I've written. We also have the registry, which I'll show you for kind of code examples. But yeah, definitely we'll leave this up at the end of it, just some resources to kind of take away with you. But now I want to get into the demo, which is actually, hey, how do we get started with Astronomer? So to get started, what you can do is go to astronomer.io, or you can scan that QR code. If you scan that, you can use the link that's in there to actually go to, I'll share the PowerPoint resource URL to go through after, definitely, Bhargav. So here, what you have is the ability to get started free. You can also, again, go to the QR code, enter your company email, or continue with Google. You can also sign up through your cloud marketplace if you want to have, be under your Google Cloud spend, or you have, you want to go through the Azure marketplace, go through here. So put in my company email, but going to, set a password, just kind of go through the process here. It's also going to fail because I already exist here. So I've actually already created an environment, but if you just go through the login flow, all you'll be doing is just filling out a form, and then you'll get a link to go to your Astronomer environment. And when you first log in, you're going to be brought to a page that looks like this, which describes your organization. So here, have my organizational name, .eu webinar. ID, and then my audit logs. So Astronomer takes a log of all actions and activities within your organization, can export this up to 90 days. And the first thing you're going to want to do is create a workspace. So workspace, or actually, before you even do that, is create a cluster. So something unique about Astronomer is that instead of requiring each new Airflow environment to have its own independent cluster, you actually will be deploying multiple Airflow environments on a single cluster. But you can also have many clusters from many different cloud providers located within the same Astronomer organization. So Azure, here I can create another cluster, and then onto these clusters are where we're actually going to deploy our Airflow environments. And so what is really great about this is you can have your networking set up at the cluster level, the permissions and routing, things like peering to allow this cluster to act as if it were a part of your network, but also control exactly what traffic goes in and out of this cluster, and then have those networking configurations take application to every single Airflow environment that is deployed into that cluster. So you set up your networking once, and then each Airflow environment can inherit off of it, which makes it a lot easier to create new Airflow environments, onboard new teams, and do a variety of things around networking. So if I go over here to expand after I've created a cluster, so I already have one available in AWS, the next thing you're going to do is set up a workspace. So workspaces in Astronomer essentially act as folders of Airflow environments. So within these folders, we can set access for either individual users or teams of Airflow users that we want to have access. And we can add those users. We go back out to our organization settings through this access management tab. There also is, and I won't set this up today because I unfortunately don't have a managed domain under my control. But if instead of adding users manually, what you can do is set up a managed domain and SSO configuration. And then we also have SCIM federation options where you can then add users to an app or to a team within your SSO provider, and then have them automatically have access through here through either a default role or through a skim federated role that's assigned to their team within their SSO provider. But just to add an individual user here, so if I wanted to go invite a user, Andre at astronomer.io, typically you're going to want to onboard new users as members, give them a low level of access. Obviously, me as an admin, I want that high level of access because I want to show you all the cool stuff I can do. But typically, you want to operate on a least permissions-based access control method. And then what it'll also do is create a team. So I'll create EU team, have an organization role. Again, I'm just going to assign them a member role, and then I'm going to add Andre to this team, create this team, and then I'm going to assign this team to have access to a workspace. So if I go into this workspace, add a team here, and then again, I'll just add a workspace member there. And so now they have access to this workspace and all the Airflow environments I'm going to create within here. Something else to note is every single action you're seeing me take can all be automated. So you can create an organizational API token, and then we have a platform API that has endpoints to automate all the steps I just showed you. So creating new teams, creating a workspace, users, managing users, which is really what you're going to want to be doing at scale. Fundamentally, I mean, functionally, you're not going to want to have to do this when you're managing, 10, 20, 30 Airflow teams. We have people that are managing thousands of Airflow environments here. And so doing that manually just isn't possible. So that's where, you will want to use these tokens, but obviously provide UI endpoints for every single action as well. You also have the option to define custom roles. So if our default roles aren't sufficient to your privacy security needs, you can define your own custom roles. And you can see here you have a role matrix you can fill out to define which jobs you'll have access to. You also have an IP access list, so you can restrict which IPs can access your range on Astronomer as well. If you want to lock out certain IPs from being able to access your UI, you can do that here. So that's just kind of high level, setting up the organization, creating our first workspace, adding a team, adding some users. Now it's time to create some Airflow environments. So here, what we're going to do is create new deployment. I'm going to create this, call you EU Airflow prod. And then here I'm going to choose a standard or dedicated cluster. So when I was referring to one cluster being able to support many Airflow environments, that has two different modalities to how you can deploy. The option I just showed you where I created a cluster and then I can deploy an Airflow environment onto that cluster is a dedicated cluster. And that's where if you provision a dedicated cluster, that is provisioned in a virtual private network that is deployed exclusively for you. You control all ingress and egress traffic. You control all private networking. You can set up whatever kind of private networking parameters you need. And then, like I described, that will take effect for all Airflow environments deployed onto that cluster. For a standard cluster, if you don't have really strict private networking concerns and you're fine with having shared infrastructure that is logically isolated. So on either option, your individual Airflow environments are completely logically isolated from each other. So they don't share resources. They don't share the same common pool of resources. There's no way to, have kind of that noisy neighbor problem where one, environment can interact with and consume resources from another. But they are, at the end of the day, running on shared infrastructure and thus have a smaller array of private networking options available because you can't authenticate at a shared cluster level. But whatever one you choose, you'll select that here, and I'll just use a dedicated one just for easy use here. And then after that, I also will choose my Astro runtime. So your Astro runtime is effectively our security hardened version of open source Airflow. And it's also a version that if anyone finds a bug or vulnerability in open source Airflow, we're able to patch and release a fix to that much faster through our Astro runtime. It's fully cross-compatible with Airflow, but it is our own package version. So if there's a bug, we can fix that, push it out to our customers in around 12 hours versus taking around 72 hours for the open source project to go through any kind of change. You also can choose your executor here. So whether you use Celery or Kubernetes executor, both of these are supported on Astronomer. And then for the Celery executor specifically, Astronomer provides a lot of extra value because you have the option to have different worker queues. And so different worker queues, if I provision one here, allow you to have different sizes of workers that then can be defined at the task level and assigned to different jobs. So for each task, you can just add a field that says Q equals MLOps. And so for tasks that might require a little more horsepower, like an ML operation, maybe training a model or doing some on-disk Python transformations, you can then give that extra horsepower to just the job that needs it. So the rest of the jobs that are maybe more traditional Airflow operations where they don't require a ton of compute can still run on that smaller size of worker, while only those new jobs or those ML jobs that are really hungry for compute will run on that specific worker just for that. So making sure you have the compute you need it where you need it. And then additionally, any changes you make to this, so if you want to change the Astro runtime version, you deploy new code, none of those require any downtime for any running DAGs or tasks. So when you make a change to your code, that when that's pushed, your code is then any running DAGs and tasks will continue to run on the worker nodes that are already running them. And then as new DAGs and tasks are triggered after that point of change, those will be triggered to be running on the new worker using the new Docker image that you have just pushed. Then down here under advanced, so last few configuration options, here you have the development mode. So this is where you can set those hibernation schedules I touched on earlier. So these are schedules where you can say, hey, I am going to set this environment to sleep during non-working hours because I don't need it during non-working hours. And the beauty of Astronomer is you only pay for the compute that you're using. So you're only paying for the scheduler and then the amount of workers that you're using. And so if you're hibernating and you're not using it during non-working hours, you're not paying for it. And so you can set these schedules. You can also have this happen manually or triggered through an API. So you can enhance that branch-based workflow I talked about earlier. We're saying, hey, developer can deploy code, have an environment come up, and then go into hibernation mode after 2 hours, so you're saving resources. You can also change your size of scheduler, and any of these configurations can all be changed after the environment is created as well, so you're not locked in if you decide, hey, maybe I don't need this large of a scheduler or don't need this large of a worker. But once you've filled out all of these different options, and also CI/CD enforcement, this will lock this environment to only being deployed to from a CI/CD token. Not going to use this right now because I want to be able to deploy for my local environment, but just want to touch on that. And then just to create environment here. And while this is creating, and almost create another one, EU Airflow dev. And then so cool. Now, while these are Airflow environments are creating, it'll take around 2 to 3 minutes to actually create. Want to show you how you can set up a local dev environment. So this is all possible because of the Astro CLI. So if you want to download the Astro CLI, brew install Astro. I already have it, so this is likely not going to work, or it's just going to update it if I'm out of date. But once you run brew install Astro, you can start a new Airflow environment. I'm just going to create a window here. Opening up a new folder. So if I open up terminal again here, and see desktop. Create a new directory, EU webinar. See it's there. You can then do something like run Astro dev init. And then what this will do is create all the different Airflow directories you'll actually need to run an Astro runtime. So if I then open this up real quick, to repos. So here, if I open this up in VS Code, you'll see I have my requirements file where I can put any Python packages, packages file for things like ODBC drivers, my Docker file for setting my Airflow version, my Astro runtime version, DAGs folder here for writing my DAGs. But if you're like me, you don't want to have to start from scratch. And most of the time, your organization isn't going to be starting from scratch. And that's where the packaging format of this Astro runtime comes in handy. So number one, we have this registry, registryastronomer.io. This is essentially just a resource for free DAGs, free Docker images that you can use as essentially starting point. So we're saying, hey, I don't know how to do something. I don't know how to use this new feature. I want to see how to use it in production. And I want to see it from the Airflow pros. That's who develops these. And so here, if I go into, say, Taskflow API example DAG here, you can see I can view the code and copy and paste the code like this. But I can also view this code on GitHub. And this is likely where you as a developer would have your code that, your central admin team, your platform team gives you this base image of. Let me find something slightly more interesting. Here we go. So with these, what you can do is if I go download, take this repo, download this zip, or just branch, use the CLI into my local environment. What I can do is go into now, open this up just as I opened up my previous environment. And started up with all the packages requirements that were installed in there in my machine. So awesome. And then all you do to start up this environment and start running it on your local environment is run Astro dev start. And then you'll see if I go and open up Docker Desktop, these are some other environments I have running. So you can actually have many different Airflow projects. If you want to just create a quick new safe space, you can run Astro dev init, load that up, not affect your under environment, and really easily switch into it. But while this is running up, I will just go into code and kind of show you what an actual environment looks like. So here you have in your requirements.txt file, this is where you have things like, hey, I want to use the Postgres provider. I want to use the Common SQL provider, the Snowflake provider. I also want to have, a Docker file using whatever version I find. So up to this 12.6, unpin these providers as well. Those will cause me some issues if I try to deploy this code. And save. Save. And then here within my DAGs, so there I have all my DAGs that, ostensibly my organization might use, can develop my own DAGs independently now. So if I go to, closed if this has started up yet, which it hasn't, I will have my own Airflow environment up and running on my local machine, ready to be used. And so here, this allows you, each you develop as developers to develop completely independently. So you don't need to be relying on, hey, I need to go use a shared dev environment, or if I make any changes here, when I go to deploy them, I'm going to have to make some changes to them to actually have them take effect. Not true. So here to deploy, I run Astro deploy. Here, we'll see if my deployments are up and ready. List. Workspace switch. So as I described, every endpoint has a CLI and API endpoint. Type it out right. Okay. There we go. Lovely case sensitivity, but you get to see some real life troubleshooting on these webinars. So then Astro deployment list, this will give me a list of all my Astro environments that are currently running my deployment, which it looks like there's one that's healthy. Deploy. 1 second. Workspace today. So if you can't type in the name right, like I can't, you can also just use the Astro workspace ID and use it that way. There we go. Awesome. So now Astro deploy. Here we go. So now I'm going to deploy into our dev environment first. Show you some, and I think my Docker local Docker environment is having some lovely issues, which is great. So 1 second. Apologies for this, but essentially, so what you'll be doing here normally, if you don't have instantaneous CI/CD problems with me, because I'm doing a lot of crazy stuff on my machine here. What you would do here is then you'd have this Astro image be built and deployed. But functionally, what you'll be doing most of the time is actually having them run from your CI/CD pipeline. So here, this is an example of what a CI/CD pipeline with Astronomer looks like. So here what you have is actually, hey, I'm not actually going to be deploying code from my local machine because you don't want your developers deploying code with no checks and balances into environments. So what you really want to have is something like this, where I log in, I take a branch from this GitHub dev branch and then extend that. Then when I'm ready to deploy that code that I've developed locally, I then push that code into the dev branch, and then that pushes that code into my development Airflow environment. Then correspondingly, once that a pull request has been opened and closed into my main branch, then that signifies, hey, this admin has looked at my code, approved it, and can then deploy it into my production environment. And so this is essentially automates the entire CI/CD process, and has you use your CI/CD tooling as the way to manage code deploys up and down through environments. You have a record of it, you have controls, and then also through those controls, you can give people greater flexibility in developing in their lower environments because you have checks and balances against any kind of bad code or nefarious code, potentially making it into production environments. So really useful tool here. And then once your code is in your Airflow environment, I want to show you kind of what a running Airflow environment looks like in Astronomer. And so I'll do is open up my own Airflow environment. And also something to note too on CI/CD is this is available for any CI/CD provider you have. So all of these actions that you're seeing that are within GitHub Actions are also applicable through our API endpoints, CLI endpoints, and then can be used with those providers through those API endpoints. So really flexible deployment, but I just like this example because it's very simple to show, but it really kind of shows how easy it is to set up and deploy production grade CI/CD pipeline. I mean, this is what many large organizations will have. It's essentially just this. So let's say, now you have a running Airflow environment where you've been running Airflow for a while. How does Astro make that easier? So number one, give you all the metrics monitoring you need, and also the ability to revert back when things go wrong. So you can see here first under this deployment overview, here I have the option to roll back to any previously deployed version of an Airflow environment. So let's say I push some bad code, an update goes wrong, I didn't catch something. I can just type in rollback here, and this will roll back this Airflow environment, deploy it onto its previous running version, and then have that up and running, and again, 2 to 3 minutes. So really de-risks upgrading and making changes. Then with the encouragement to, we want to help you develop faster, make use of these new features because they can really help you in your organization run Airflow more efficiently and more cost effectively. So now onto the analytics tab, you have here some information around not only your task runs and DAG runs, but also your memory usage per pod, storage usage per pod. And what's really useful here is the ability to then isolate these by worker queues. And so here, if you want to just look at how a particular subset of DAG or even an individual DAG that you only use a particular worker queue for, here you can monitor exactly how that DAG or group of DAGs interacts with its underlying compute, and then use that to optimize it and say, hey, maybe I actually don't need this much compute for these DAGs and I can lower them. And you're just having those kind of second level insights that you don't just get from explicit DAG failures or DAG success states. As always, if you want to open up Airflow and monitor your running DAGs and tasks, you can always hit open Airflow, open up a DAG, have all of that available to you. So the traditional Airflow UI, everyone knows and sometimes loves, sometimes hates. I'm a personal fan, but everyone has their opinion on it. And then going back in analytics here, so you also have the option to look at your logs for every component of the Airflow environment. So a lot of times, you'll have failures that aren't actually caused by something wrong with the task or the code, but it's something wrong with the actual component. We expose those to you. But then we also have this health indicator that has alerts automatically set on it. So if you'll have an environment where the scheduler goes down or the web server becomes available or tasks are getting stuck in queue and you're getting some zombie tasks, you'll get, number one, an indicator in the UI that tells you that that has happened, but you'll also receive alerts that notifying you that that's happened as well, because you don't want to spend your day logging into Airflow and checking on your environments. What you want to have is a proactive alerting system to let you know when things are going wrong, so you know immediately to go there and fix it and don't waste time sitting there watching things go perfectly. You also have the option to set environment variables here. And this is also really useful if you have environment variables you're trying to test out, so you don't have to rebuild your environment every time you rebuild a new Airflow environment variable. And these also can be shared across environments. Similarly, we have a built-in connection management system. So I can either view it on a per deployment level or go to this environment tab. And this is where, if you don't have a secrets manager, great alternative to one where you can create, a new connection, new GYU, type in some details here, and then you can choose to automatically link this to all deployments if it's a connection that you don't really care about, you don't mind if everyone has access to, just hit create connection here. And then here, this will make it available to all deployments. If you have a connection that you only want to be available to one or a few different deployments, you also can just say, hey, I want to add this explicitly to this deployment. Maybe there's a parameter you want to override here. So test, I think actually someone is using this. I'm going to choose one that looks a little bit less useful. Cool, this one. So here, if I link a deployment, I can actually override any of these values. So you can have a base connection where then, hey, maybe I'm overriding for prod, that's going to use the prod table and the prod user, or dev, it's going to use the dev table and the dev user, and have that all happen automatically, while the actual name of the value, the connection ID, stays the same. So the underlying connection changes, but you don't have to change the code or have logic in your code that says, hey, use this connection or this one, and just kind of reducing those points of failure there. And then also, if you set these as secret, or a lot of these are by default secret, once you enter a value in there, it's never exposed after you save or update that connection link. Then back on the deployment level, so you also have the option to set per deployment roles, and you also can assign teams to per deployments. So that's also why I recommend that least privilege access control. So you only give them access to workspace and owner, and then explicitly grant users access to individual deployments that they need, or teams access to, let's say a dev environment that they need. So really just keeping everyone assigned to specifically the environments they need to have access to, so people don't screw up each other's work, no one steps on each other's toes. You also have the option to create API tokens too here, and then alerts. So here you can actually see a record of sent failed alerts. So these are the default alerts that are created to notify you of, hey, this tag has gone wrong, or this Airflow environment is not healthy. But you also have the Astro alerting UI. And so actually, if I go out of here and go, so you can create them at a deployment level, but you can also go and create alerts at a more macro level across your organization. And this is also all automatable through an API that's kind of coming out, I think, yesterday. And so here you can set alerts on things like DAG failure, success, timeliness, DAG duration, and things also like a true task duration. So this is actually built on the Astro hypervisor, which is built around all the Airflow environments that Astronomer is managing. So instead of relying on Airflow's flawed SLAs, where you'll only get a notification that's measured, this duration is measured from the beginning of the DAG, not the beginning of the task, You also only get a notification if that task ultimately fails or if it, it ends up crashing, right? So if the task gets stuck in a zombie state, you just won't get an alert. Or if it exceeds its SLA, but just ends up in a hung state, you're not going to get an alert. So here, what the Astro hypervisor does is consume the lineage data that's now generated by default in open source Airflow and the Astro runtime from 2.7 onwards, and uses that to power this loading system where it's constantly monitoring and consuming all of that information and using that to power an alerting stack that doesn't require you to have code and callback functions instituted in every single DAG, and just weighing your entire DAG code down with a ton of boilerplate code. Here, you can just select a workspace, select the deployment, select any DAGs within that environment, and then select any tasks that are within those DAGs. Again, automatable through an API. And then you also can go here and create a notification channel. So we have Slack, PagerDuty, OpsGenie, and email available as just kind of default. Fill out your details here. This DAG trigger alert actually also allows you to have a payload of a notification that you can then take and pipe out to whatever notification channel you're using. So you just set up one DAG that processes this alert and then pipes it out to a specified location and can introduce any other logic or, so common use cases, Teams. A lot of people use this for sending out alerts to Teams channels, but really allows you to implement alerts at scale. And alerts are the best way to monitor Airflow, so you're not stuck having to monitor it passively or just actively. Even when your DAGs are running fine, you just get timely alerts exactly when things go wrong. And also, when things are about to go wrong, even if you miss an SLA and you don't have an explicit failure, you still have a notification channel of it. So that is almost everything I want to talk on the team level. I also managing, if you're managing multiple Airflow environments within a single team, we also make it easy to manage all the DAGs across those environments. Or, I've seen some teams that have 6,000 DAGs and they've come to the point where they want to start splitting those up across environments, but they don't want to lose that unified DAG search view. You can still preserve that with this DAGs pane here, where you can filter by particular deployment, but also filter by tag, DAG name, open up these DAGs as if they were in the Airflow UI, essentially one-to-one. Look at the code, run retries, look at logs. Also, look at some of our new AI log summary features. So this is something we're coming out with to help you solve and fix your pipelines quicker. And then also here is Astro Notebooks. So this is something that we developed to essentially allow you to have an easier way to get started with Airflow. So here, this is more meant for data scientists or people that aren't really comfortable using Airflow and writing full DAG code, but they still want to get some value out of Airflow. And so here, what you can do is define Python, SQL code, but also just form-based operators. So instead of needing to define all the code around a BigQuery operator, I can just define the SQL string I want to run, and then have this just use a connection that you as an admin can then set up within the UI here. So we'll go into environment here. So here you can see I have like my Snowflake connections available to me, run SQL code in them. Don't need to have a lot of technical expertise to use this, but on the back end, this spits out functional DAG code written in the best possible syntax. And so really good way to bridge the gap. Also can hook into your CI/CD pipeline so you can commit to a specific branch. And it's just generally a really good tool to help people get started with Airflow. And you can also set up a dedicated environment for them to run this code into if you want to kind of segment them from the rest of your running Airflow code, which, to be honest, you're probably going to want to do. And that's just something I really want to show that's useful to some people. Some people just prefer to develop the old Airflow way. I know I do, but some people really love it. And then finally, and just kind of want to wrap this up with Astro dashboards. So Astro dashboards are a tool for, as I talked about, a lot about managing Airflow at a really large scale. And that requires really strong analytics tools out of the box that are automatically intaking information from new environments, new teams that are onboarded and offboarded. And so here you have this organizational overview looking at, how many deployments you have running, your task counts by success, failure state, active DAGs, view of your most active workspaces. But then something that always gets people excited is this cost breakdown page. So here you can look at exactly which teams are consuming what resources, how much it's costing them for those resources. So if you have any kind of chargeback model, this is a godsend. But you can see here, exactly which compute is being used, what type of scheduler is being used on a per deployment level. So really granular cost attribution here. And you can pair this with worker queues to really understand, hey, how is a bundle of DAGs actually consuming resources? Also, under deployment detail, this is where you can look at all of your deployments across your different workspaces. As an admin, make sure everyone's in compliance with Astro runtime versions. Make sure, check their executor, high availability, general form factor. Also monitor for, inactive environments, maybe environments that can be cleaned up and deleted because they're no longer being used, and just giving you that single pane of glass view. Then you also have your DAG run detail page. So this is really useful for understanding how certain DAGs are performing over time against their SLAs or just against their average. So you can see, hey, why is this starting to trend in the wrong direction? And so you can see here, this is, day by day average DAG run end time versus its expected end time. You can also look at the average run duration. You can see this DAG has started to perform worse and worse over time, which isn't really a great sign. But just, really easy to have this information for as many DAGs as you need across any of your workspaces and understand how your DAGs are performing. And then finally, operator use. So this is where you can look at top operators across your organization, monitor, make sure people are using the right operators, staying in compliance, and using the operators that you provided for them. And that is everything I wanted to show you. Would love any questions, any comments. Love to handle them.
Thanks, George. We had a question on OSS customizations and plugins. Would you be able to touch on how Astronomer works with those and if we support any of those?
Yeah, so we're fully supportive of any plugins, any customizations you might have made to open source Airflow. If you built a really crazy custom calendar, you can bring that over with you. So we actually have a dedicated folder or you can add a dedicated folder for plugins. If I go to the new environment I created, you can actually see that there. So we are very, very customizable. You can even have this Docker image replaced with the one that you inherit from our runtime, pass through your own security systems and patches, and then release from here as well. So a lot of flexibility in supporting those kind of customizations you might have made.
Awesome. Thank you so much. And then one other question I see is just how can I set up private networking for Astro environments?
Yeah, so there's a few different ways you can set that up. So number one is at the cluster level. So as I described here, you have the option to set up things like VPC peering connections. You can see this one has already been created. You can also create your own VPC peering connections, just filling out this ID with your AWS credentials. You can define your own routes as well. So CIDR routes, and kind of, CIDR blocks, make sure your IPs are routed correctly. Then you can also authorize this to particular workspaces. So saying, in this example, any workspace can create a deployment on this cluster, or you can authorize different clusters to different workspaces. And then here as well, if you want to configure customer managed egress, this is where you can set up your own transit gateway and really fully control all ingress and egress from your networking.
Great, thank you. And then I saw one last question that I think Andre on our team was already able to answer, but we had one question come in. I believe when you were talking about Airflow, can it be integrated with IBM Watson X.data? Andre mentioned that, yes, Airflow can be integrated with any technology. And if there's not a provider or package already created, it can always be done via code. Is there anything else that you would want to add to that?
Yeah, no, Watson Dex Data and IBM, they're big supporters of Airflow and Astronomer. So 100%, you are able to automate all watsonx data workflows. And you guys know watsonx data does have some good APIs, good external controls that Airflow can plug into and manage there. So definitely possible. And just to highlight that too, watsonx data actually published their own article on it.
Great. Thank you so much. Those are all of the questions that I see for right now, but if anybody else has any other questions, definitely just submit it through the Q&A or put it in the chat and we can definitely try to answer before we hop off. And also just to know, everybody will be receiving a copy of the recording, so you can always go back and watch anything that you might have missed or want to rewatch on demand. And if those are all the questions, I think we can end a little bit early. Anything else you want to add, George?
I don't think so. It was an absolute pleasure speaking to you all today. And yeah, we'll get that slide deck out and those resources.
Sounds good. Thank you everybody for joining, and thank you, George, for sharing all this information.
Of course, good one, y'all.